You might be familiar with cryptocurrency exchanges such as Coinbase and Binance. These are centralized for-profit companies that offer websites and apps where you can buy and sell digital assets like coins and tokens. Coinbase has monopolized crypto exchange in the US, and Binance in pretty much rest of the world. This is bad. When the world's money flows through centralized points of failure, they can be hijacked by authoritarians to do bad things, like seizing the funds of their political opponents, or even financing wars. Programmable blockchains like Ethereum address this issue by being decentralized at the base layer. So, how could we run an exchange on a blockchain? At the heart of the centralized exchange lies the order book. It allows people to buy and sell tokens by placing simple orders. Consider an order book for trading a pair of two tokens, a generic X token and the dollar, which we show with the symbols XXX and USD. We chose a dollar over a generic Y token because it makes it easier to represent prices. In this example, Alice has $20, which she would like to trade for 10 X tokens. In other words, she is willing to buy 10 X tokens at a price of $2 per 1 X token, so she places an order just for that. Bob, on the other hand, wants to sell his X tokens to buy some dollars. He has 10 X tokens and finds Alice's price reasonable, so he places an order to sell all of it at a price of 2. This is when the magic happens. Each order book comes with an algorithmic system called a matching engine that keeps an eye on all orders and executes a trade when it sees a coincidence of ones. In this case, it sees that Bob can exchange with Alice at the same price, so it executes a trade. Alice and Bob get what they want and both orders get filled, meaning they are closed. This is the gist of how order books work. So to implement one on a blockchain, we would need to somehow create this order functionality. Let's take a deeper look into what an order is. It is just a permission given to the exchange to trade funds at a future time when the condition set by the user is fulfilled. And that can only happen when the matching engine can find another order that is willing to trade at the same price. Placing an order at T1 doesn't do anything to the X token and dollar balances of Alice immediately, or for Bob when he submits his order at T2. The funds they designate are put in escrow, meaning they are frozen and can only be moved by the matching engine. The trade happens at a future time T3, only when the conditions are met and the matching engine decides it's time to execute it. So for a single trade to happen, at least 3 separate computations must take place at times T1, T2, and T3. And that doesn't even include all the internal operations that the matching engine has to perform, like sorting and queuing the orders in an optimal way.